In the span of just 72 hours, the universe seemed to erupt in chaos, unleashing a storm of cosmic and earthly violence that no one could have predicted. Two distant stars detonated with such brilliance they became visible to the naked eye. Venezuela was shaken by twin magnitude 6 earthquakes, and above it all, the sun hurled a colossal coronal mass ejection straight into the path of the only confirmed interstellar comet currently slicing through our skies. 3I Atlas. Astronomers call this rare overlap of disasters the 72-hour stack, a convergence so improbable it reads more like science fiction than reality. What made this moment terrifying wasn't simply each event on its own, it was the way they collided in time. The odds of such a pileup of novae, seismic shocks, and a solar storm all landing in the same 3-day window fall to less than 1 in 1,000. Some researchers suggest it might even be far rarer, the kind of alignment statistics almost refuse to calculate. Was this a bizarre accident of randomness, or is it a pattern we've only just begun to notice? Think about it. On average, Earth sees maybe one nova visible to the naked eye in an entire year, sometimes none at all. Yet in those 72 hours, 2 stellar explosions lit up the night sky for backyard stargazers. In Venezuela, where a quake of magnitude 6 might appear once every 2 or 3 years, the ground split open twice in less than 6 hours, followed by a powerful aftershock, and just as the dust rose, the sun, already raging at the height of its activity cycle, launched a coronal storm directly across the orbital track of 3I Atlas, a visitor so rare it's only the 3rd interstellar object humanity has ever confirmed. This was not a week that followed the rules of probability. It was a week when the universe itself seemed to throw out the rulebook, and here on Lumora, we're going to break it down moment by moment to understand how this impossible storm of events truly unfolded. To grasp how unlikely this cascade was, you have to break it into pieces. Start with the novae. Naked-eye novae are among the rarest spectacles in astronomy. A typical year may bring one, sometimes none at all, but in this strange sequence, 2 separate stars flared with enough intensity to be spotted without even a telescope, and they did so just a day and a half apart. For ordinary skywatchers, it meant stepping outside and seeing stars literally reborn in real time. For scientists, it was a statistical anomaly that defied expectations. Now shift to Venezuela. Earthquakes there are not unusual, but the numbers matter. A magnitude 6 quake usually strikes the region once every 2 to 3 years, yet in less than 6 hours, 2 major shocks ripped through the same zone, followed by a magnitude 5.8 aftershock. The ground convulsed so quickly that the usual cycle of stress and release seemed compressed into a single night. People were jolted awake, hospitals scrambled, and seismologists found themselves mapping ruptures before they could even catch their breath. And above Earth, the sun was no calmer. At the peak of its cycle, the solar surface boiled with activity. A coronal mass ejection, or CME, erupted outward, 1 billion tons of charged plasma flung across the solar system. CMEs are not rare, but their timing here was extraordinary. This particular blast intersected with the orbital path of 3I Atlas, the interstellar wanderer moving at nearly 60 kilometers per second. A target so unique, it's only the 3rd of its kind humanity has ever observed. When you stack these odds, the double nova, the double quake, and the solar storm brushing past an interstellar comet, the probabilities collapse into the almost impossible. Statisticians call this Poisson clustering, where randomness produces outcomes so extreme they feel loaded. The result? A week when the universe itself staged an event stack, a collision of sky and earth that felt less like chance and more like fate. The timeline of this extraordinary stack begins ticking just past midnight, universal time. At 2:12 a.m. on September 23rd, the first nova, catalogued as V1935 Centauri, flared into visibility. Survey telescopes in Chile and South Africa picked it up almost instantly, their automated systems sending alerts across global networks. Within an hour, confirmation rippled through the astronomical community. For Europe, it was dawn, and astronomers awoke to news that a dead star had just blazed back into sight. Barely 36 hours later, the Earth itself joined the drama. On the evening of September 24th at exactly 22:21 UTC, seismographs across the Caribbean spiked with violent activity. A magnitude 6.2 earthquake tore through Mene Grande, Venezuela, its epicenter shallow, just under 8 kilometers deep. For residents, it struck just after dinner, lights swaying, power lines groaning. Preliminary reports streamed into seismic centers within minutes, amplified across WhatsApp groups and local radio stations. But the ground had not finished moving. Less than 6 hours later, at 3:51 a.m. UTC on September 25th, another rupture jolted the same region awake. This second quake, a magnitude 6.3, came from slightly deeper, around 14 kilometers, but it delivered no less chaos. Within the hour, a 5.8 aftershock rippled through, forcing terrified families out into the streets once again. Hospitals documented the chaos in real time, staff using time-stamped messages to coordinate patient triage, supplies, and emergency evacuations. And then, in a cruel twist of timing, just 14 minutes after the second quake, the sky flared again. At 4:05 a.m. UTC, Nova V7994 Sagittarii erupted into brightness, peaking at magnitude 6.2. This second stellar detonation wasn't just visible. It carried with it signatures across gamma and X-ray wavelengths. Amateur astronomers rushed to compare notes with professionals, their reports flooding Discord channels and Twitter feeds. In less than 3 days, the Earth and heavens had delivered a sequence of shocks that felt less like coincidence and more like a cosmic script. A nova is far more than just a star growing brighter. It is the violent rebirth of a dead sun, a white dwarf that has spent eons stealing hydrogen from its companion star until the pressure on its surface rises to an unbearable limit. At that point, fusion ignites in a runaway flash, detonating the accumulated gas in a thermonuclear blast. In a matter of hours, the light output can increase by a factor of 100,000, outshining entire galaxies from across unimaginable distances. That is what happened before dawn on September 23rd, when V1935 Centauri leapt to magnitude 5.8, just barely within the threshold of naked eye vision from a dark sky. The discovery itself carried a human story. Gabriela Moya, an amateur astronomer working from Valparaiso, Chile, was the first to confirm the outburst. Running remote telescope sessions through spotty internet and power cuts, she pressed on through exhaustion, scanning the skies in search of anomalies. When she finally caught the nova, she had not slept for nearly 2 days. Her report, time-stamped at 02:12 UTC, became the first official confirmation sent to the Central Bureau for Astronomical Telegrams. That alert triggered a chain reaction, automated confirmations firing across hemispheres, data flashing through global networks. What made this nova so striking wasn't only its visibility but its fingerprint. Instruments picked up not just the optical surge, but gamma rays and hard X-rays, evidence of powerful shockwaves accelerating particles to near-light speeds. Less than 2 days later, V7994 Sagittarii would erupt in much the same way, mirroring the violence and unleashing its own torrent of high-energy emissions. Scientists scrambled to parse the data. NASA teams pored over logs. Satellites like Fermi and Swift confirmed the gamma bursts, and preprints flooded the internet. Each paper probed the same haunting question. What kind of conditions ignite such ferocity, and why would two separate systems flare so closely together? For many, the sheer timing was as shocking as the physics itself, a 1-in-a-million mirror of stellar violence etched across our skies in less than 72 hours. The first Venezuelan quake struck just after sunset near Mene Grande, its magnitude 6.2 shockwave ripping upward from a shallow depth of only 7.8 kilometers. That shallowness was what made it so destructive. The rupture reached the surface with unfiltered violence, shaking homes, snapping power lines, and driving people into the streets. Hospitals, already short on supplies, were suddenly flooded with patients. Nurses dragged gurneys into parking lots as aftershocks rolled through, treating the injured under open skies. Among them was senior nurse Maricela Rivas. She had just ended her shift when the quake hit, yet minutes later she was back in uniform, her voice steady as she coordinated triage over her hospital's WhatsApp group. With walls cracked and lights flickering, staff marked color-coded tarps outside, green for minor wounds, yellow for urgent, red for critical. Volunteers rushed to rig makeshift water stations, guiding families to safe areas as more tremors loomed. 5 hours later, at 3:51 a.m., the ground convulsed again, this time a magnitude 6.3 rupture, deeper at 14 kilometers, but centered almost directly beneath the same region. The sequence unfolded in what seismologists call a stress transfer pattern, one fault slipping, loading pressure onto the next, triggering another rupture. Within the hour, a magnitude 5.8 aftershock struck, driving medical staff and patients out into the night once more. Inside the hospital, chaos became routine. Cooks became spotters, scanning walls for new cracks. Flashlights doubled as surgical lamps. Children and the most severe trauma cases were prioritized, shuffled from indoors to outdoors as tremors demanded. Local radio stations relayed every update, lists of urgently needed supplies, safe ambulance routes, and pleas for blood donations. For those hours, the hospital wasn't just a place of care. It was the nerve center of a community in crisis, holding together through improvisation and grit. Yet as destructive as they were, geologists emphasized that the Venezuelan quakes still fit Earth's rules. This stretch of crust is forever under tension, caught between the slow grind of the Caribbean and South American plates. Even in a week when the universe felt like it was breaking its own laws, the Earth, in its violence, remained true to its patterns. While Earth reeled from seismic chaos, the sun was staging its own drama. Solar maximum is not just an abstract cycle, it is the storm season of our star. By late September, sunspot counts had surged past 160, and the solar radio flux hovered above 180, both signs of a furious stellar engine near its peak. Under these conditions, coronal mass ejections, the sun's colossal storms, become almost routine, but one CME in particular was destined to stand out. Launched across space at millions of kilometers per hour, this vast plume of charged plasma barreled into the inner solar system, its trajectory intersecting with the orbit of an object unlike any other. 3I Atlas. This wasn't just another comet from the Oort cloud or Kuiper belt. It was the third confirmed interstellar visitor humanity has ever seen, an emissary from another star system, its ices and dust older than our own sun. What makes 3I Atlas so extraordinary is its orbit. Strongly retrograde, slicing against the flow of the planets, it skims close to the ecliptic at a blistering 60 kilometers per second. By October 3rd, it would pass within just 0.19 astronomical units of Mars, a close flyby already drawing the attention of orbiters eager to capture images and spectra. For planetary scientists, it was a once-in-a-lifetime chance to observe an alien body born in another stellar nursery colliding with the energy of our solar storm season. Geophysicist Dr. Stefan Burns described it as a once-in-a-generation experiment. Humanity has witnessed solar storms buffet comets before, but never an interstellar one. The physics of plasma interactions under these conditions is still murky, and 3I Atlas was offering itself as a natural probe, its coma and tail serving as sensors, tracing the invisible wind of the sun. The convergence of timing could not have been more remarkable. An alien visitor swept through our system just as the sun entered one of its most violent phases. Earthquakes shook Venezuela, stars exploded into sudden brilliance, and a CME slammed into an interstellar comet. In less than 3 days, the universe presented scientists with a series of experiments they could never have designed and might never see again. As September gave way to October, the calendar filled with cosmic appointments. Astronomers marked them like headline events in a play that refused to pause. The first date circled in red was October 20th and 21st, when another comet, C 2025 R2, better known as Swan, would make its closest approach to Earth at just 0.26 astronomical units, or about 39 million kilometers. Coinciding with a new moon in the peak of the Orionids meteor shower, the timing could not have been better. Under clear, dark skies, even small binoculars could reveal Swan's delicate tail brushing the heavens. The instructions for skywatchers were simple but precise. Head out after midnight, away from city lights, allow 30 minutes for your eyes to adjust, and carry a star chart or an app to trace Swan's faint path. Amateur astronomers across the globe prepared equipment, from 7x50 binoculars to backyard telescopes, ready to capture the comet's shimmer in long-exposure photographs. For many, it was more than a spectacle. It was a way to take part in the unfolding story of the cosmos. Then came October 29th, the date everyone was waiting for. On that day, 3I Atlas would reach perihelion, its closest approach to the Sun in this passage, about 1.36 astronomical units. Though invisible in daylight, seasoned observers whispered about attempts at dawn or twilight, with one critical caveat: safety. Without ISO-certified solar filters, even a split-second glance near the Sun can cause irreversible damage. Every article, every broadcast repeated the warning: curiosity must never come at the cost of eyesight. And the story didn't end there. December 19th loomed as the comet's closest approach to Earth, about 1.8 astronomical units away. By then, if its activity surged after perihelion, 3I/Atlas could become an accessible target for thousands of amateur imagers. Platforms like the AAVSO and Comet Observation Database were already posting calls for magnitude estimates, tail sketches, and time-lapse submissions. The universe was writing history, but it invited ordinary people to hold the pen. In just 72 hours, the universe staged a performance so improbable it bordered on impossible. 2 novae flared into naked-eye brilliance, twin earthquakes ripped through Venezuela, and a coronal mass ejection collided with the path of an interstellar comet, 3I Atlas. Each of these events alone would have been noteworthy. Together, in a single window of time, they formed what scientists now call an event stack, a convergence with odds less than 1 in 1,000. The sheer improbability is what makes it unforgettable. Statisticians talk about Poisson clustering, randomness that occasionally throws out hands so wild they seem loaded. But to those living it, the experience felt more like fate than chance. Hospital staff in Venezuela guiding patients under swaying power lines, amateur astronomers catching nova alerts on sleepless nights, solar physicists refreshing live data streams as the CME closed in. Each thread was human, fragile, and real, woven into a larger cosmic tapestry. And yet, behind the awe, the science deepened. Novae reminded us of the violence of stellar death, where white dwarfs erupt in thermonuclear fury. The Venezuelan quakes underscored the restless grind of tectonic plates, always pushing, always releasing. The sun's CME striking 3I Atlas transformed an alien visitor into a living laboratory, revealing how interstellar material responds to the fiercest storms of our star. What looked like chaos was, in truth, the raw mechanics of the universe exposed in rapid succession. The record now stands. September 23rd to 25th, 2025, a 72-hour cascade when Earth and sky seemed to conspire, when the laws of probability bent into shapes almost unrecognizable. As October and December bring new milestones, Swan's approach, Atlas's perihelion, and its closest swing past Earth, the data gathered will test whether this was coincidence or connection. Here on Lumora, we will be watching, measuring, and remembering. Because sometimes the rarest patterns of nature unfold not in theory but in plain sight, written across the stars, the ground beneath our feet, and the very winds of the sun. And when they do, they remind us of just how fragile and how extraordinary our place in the universe truly is.